Welcome, everyone. Let's do a real quick 20 minutes on some interesting data types and why they still matter on today's. So we just heard on the keynote that more features for JSON. Now regular expressions. Now this and that. I think that will keep me occupied as a SQL Server database performance tuner. My name is Claudio Silva. I work for Data Masterminds. And when I'm not doing performance tuning and living inside of SSMS, checking ugly code and seeing some beautiful execution plans and some hard work, I'm also doing some automation with PowerShell. And I'm also a contributor for the DBA tools and the DBA checks open source PowerShell modules. OK, let's go. First thing that I want to talk about. I was looking for the term that means emergency landing on water. I knew the Portuguese words. I'm from Portugal, but I was sure about what it was in English. And I found that ditching is the right term. Please correct me if I'm wrong. But if you don't know, Alexander Arvidsson is a pilot. He flies planes. And I went to that source to double check, hey, Alexander, is this really the right word? And Alexander told me, yes, it is. And as you can see, it can be very unpleasant. So why we are talking about this today? Let's pick this example. So by raising your hands, who thinks this will become true or false? True. Anyone? You know the trick, right? So it's false. SQL Server says it's false. It's not me, OK? But actually, SSMS says it's 0.3. What about if we run and you cast the fault to a different precision? SSMS still says it's 0.3. So I don't know why it's still false. What about if we sum a cast of both floats with some more precision? Here you have it, why it is false. OK? And this is a computer thing, not a SQL Server problem. OK? SQL Server was not having a bad day on this day. But the interesting part, and because everyone likes real stories, on the client, I found this problem where I was doing a performance tuning change, changing a cursor operation to a set-based operation, everything running like from 2 minutes to like 1 second. Cool, but let me confirm the results, and guess what? The results did not match. Come on, why? After commenting code, double-checking the columns, and so on, this was the problem. They were using ceiling function, which for those that doesn't know, everything that is above, even by a decimal point above a number, it will put it on the next full number, the next integer, let's say. The problem is that float is not a data type to be used with precision. So therefore, whenever you use float, make sure that you really want to use float. Because if you are working with money, and I'm not saying that that client was working with money, this can happen, and I can imagine a little bit of cents and pennies that can be wasted in this way. So the takeaway here is that it's OK to use for stuff that you measure, but you don't need a lot of precision, OK? You don't use for things you count, OK? And then on the slides you can get, but you have like a website which is like 15 zeros, OK, 4.com, and this is one of the websites that explains why this happens with computers. Okay, so this is generic. This is a problem on not a problem. It's a known issue. Let's call it that way, on any language, and it's just the way it works. So everyone will now avoid floats, right? Thank you. Next one, and varchar. I don't know how you guys speak that, but for me, it's always difficult as my second language, English. But I say and varchar or varchar max, and concatenations. So let's say that I have And by the way, the story behind this, a client sent an email and said, SQL riddle. And on the body of the email, I don't understand why this is happening. Is SQL Server drunk? And I get that very in my heart, and I say, well, let me prove you that you are wrong. Let's say we are starting with a var max. And let's say that I'm replicating the letter A 7,500 times, and I'm concatenating with the replication of the B 510. So question, why it does 8,000 characters? I was expecting 8,010. So the reason is because of the data types and the precedence, and which one, when converted, will be the final data type that we have. So what if we use Unicode? So now the A has the little n behind saying that is a Unicode, and I'm replicating with the B. And now, even worse, now I have half of my data. Why that happens? Because the output of the replicate will be a n varchar, which in the max is 4,000 without the max per se, meaning when you sum with something else, it will convert to the 4,000 by default max of the varchar, the n varchar in this case. So what about we convert our A to a max? In this case, we have the 8,010, okay? And everything is okay. I have, now I'm concatenating like 7,500 with 8,000 of a non-Unicode string, but here's the problem, the concatenation. Because it will pick the input, convert to that data type, and only then append, and if it surpasses the max, we have a cap. Meaning, in this case, if I do also the B with the n varchar max, the conversion, then I have the right size and the total string that I'm expecting. And here, just to show if we change to the n varchar, what happens, as you probably know, if we have a Unicode, each character occupies 2 bytes. So we are doubling the space needed to save this data. And yeah, in the end, the client was doing some linked server query, dynamic T-SQL to concatenate database names and stuff to then call the linked server on the linked server. And the problem was that he missed the N for the Unicode in one of the concatenations, and all of a sudden the string was being cut. Problem, sometimes it worked, sometimes it did not, because we were just on the border between the max that was possible. Now, another example, 2 columns. Imagine a table with a big int and a GUID, but of course should not be easy. It's a GUID, which is not a GUID data type. It's not a unique identifier. That would be too easy. Was a n varchar 50. Again, real table on the client. So let's say that each record that we have, on average, is 80 bytes. 8 bytes from the big int, and let's say if you have a GUID, so the string with the dashes and all the other characters have 32 characters. Meaning that in this case, if we set an average of 72 bytes to that one, we will get for 1 million records, 80 megs, for 1 billion, 80 gig, and then if you have 14 billion, you will have like 1.2 terabytes. And don't forget, it's just 2 columns, okay? But if I query the table to check what was the max length of that GUID data type, it was actually 36. Meaning that if I use a varchar instead of n varchar, I will right away, on average, reduce my size kind of, let's say, an half. Why I'm saving n varchar data to save regular characters, right? But someone decided to use n varchar in this case. So what is the story behind this? Never-ending growing table that gets some data, is inserted, and no housekeeping in place. When we asked why, Because yes. So how can we, oh yeah, you can delete data if all these 5 conditions were met. So we have the query to check that, and we start deleting. Imagine where it starts. So just for you to have an idea, we went from 14.4 billion records, sorry, to 300 million, and from 2.2 terabytes to 200 megabytes. So terabytes to megabytes, okay? And to be honest, we even not try to compress the table, okay? To compress this one. So takeaway, on the strings, be aware of the truncation. Try to use always the same data type when concatenating stuff. And on tables, always try to choose the right type and size. So that is needed for your data. Why is this important? Because imagine that you need to refresh environments. You need to do backups for that. You will need storage to get those backups there. Then, whenever you are working with the data, you need to read from the disk and put it on the buffer pool. Whenever you run a query, depending on the data types that you have and the size, if you need to order data or the engine needs to do some hash match operations, it will need to get memory grants. If you cannot get a memory grant, the query won't start running. If the query won't start running, you will get some timeouts. And if you get some timeouts, someone will be sad. So if you think about this, everything is kind of correlated, and that's why it's important to keep this in mind, because it's like a small thing, but when you append on all the points, in this example, and maybe you have others, that will be something that will explode on the data that you need and the time that the things will take and so on. Next one, partition elimination. Is anyone using partition tables? Yeah. So first and foremost, partitioning is not a performance feature, okay? Partitioning is cool to move data around with metadata and stuff, okay? However, I may say that if partition is already there, if the client is using partitioning, we can get a benefit using partition elimination. Anyone doesn't know what partition elimination is? Okay, so partition elimination, as we will see, is the ability that the engine has to filter the amount of partitions that needs to be read to get your data. Let's say this example. We have a table with an event date time, and we run a query saying that we have X records, 1,000 in this case, where the event date is bigger than our variable. What we see here is that we have a cluster index seek. Seek are good, right? However, pay attention that we have, I cannot zoom in here, 1 to 5 is what you can read here, meaning that I have 5 partitions on my table, and all the 5 were touched, were accessed to read the data. So imagine you have a table partitioned by day, you have 360 partitions on a year, you run a query, and the engine says, well, because I cannot use partition elimination, let me run through 1st of January until the end of December to get the data. But if we can use the column on which we are doing the partitioning, the engine can rely on that to say, well, if you are asking me the last 24 hours, I can skip 300 and I don't know how many partitions and go direct to just this partition, which is not happening here. So, and why? The date time 2 that I'm using as a variable is not of the same precision as the date time 2 that I have on the table. So if you don't have the same data type with the same precision, in this case is the date time, the engine cannot do a safe assumption that I will rely on the data because otherwise I can miss some bits and bytes. So in this case, if I change the query to use the date time 0, and I still have my cluster index, but now, look, only the partition number 5 was accessed. This is a small table. This is just for the example. I have seen this being 1 ... 10,000. Okay? I can also say that we did an improvement on the ETL process from 12 hours to less than 2 hours, where the majority of the change was adding 3 characters on the parameter of the store procedures. Okay? And here is the combination and what happened in this case. Yeah, and with that, more examples that we could talk about. So we already talked about memory grants. Don't forget that with memory grants, if a query needs a memory grant, and if you have like nvarchar max and stuff, the average size of a record that will be calculated is big. And if you are trying to read thousands or millions of records, you need to multiply that. And that's why sometimes you see queries requesting 80 gigabytes to run an ETL report, or a report on top of the data that you have. It's also important for the sorts, because you need memory to sort the data. And in that case, you will probably start seeing, or you may see some resource semaphore weight type, which means that the amount of memory that you have cannot be granted to the query, or that the query needs. You cannot grant it. So imagine if you have a 4 gigabyte server, you have a query requesting 1 gigabyte to run a query, you cannot run 5 queries in parallel. The 5th one will start having resource semaphore, and only when one of the others finish and release the memory, the other one will start. But if you run SPU is active, SPU, you will see the session is already counting, running on time. But the query, the data is not being accessed and not being done. So if it takes 20 seconds and then it takes another 15 seconds to run, these 35 seconds probably will give you a timeout if we think about the default 30-second timeout on the .NET or the drivers, okay? The other one also to mention here, implicit conversions, I think is maybe more familiar for everyone. When we use not the right data type to doing comparisons, and then the engine says, well, I cannot compare carrots with cabbage. Let me pick on these carrots, convert to cabbage, and then do it. And to do that, you go to the index. Doesn't matter if it is the cluster or the non-cluster, but it will need to scan the index to convert that data, and only after it's able to do the comparison. And that will be lots and lots of CPU cycles and I/O being done that are not needed, probably. And most of the times, these ones are interesting, and with Link, Entity Framework, Hibernate, and stuff, it happens a lot of times, okay? And if you have queries that run 1,000 times per second, having an implicit conversion can be the difference between running on very low CPU or all of a sudden you are on the top for a long time. Questions? Anyone? So I will ask you if you can provide feedback, and I take the chance to say that for the feedback, even if you don't want to give feedback to me, please give feedback for the charity, because SQLBits is providing money for charity for each feedback was sent, okay? And secondly, yesterday I did a 100-minute session with lots of data, lots of demos with performance. And I have demos, because in 20 minutes I cannot do the demos, but I have demos for these data types thing. And tomorrow at 10:10, we'll have a session, 50-minute session, which is a kind of continuation of the yesterday session, but with the rest of the demos that I was not able to show yesterday. So if you want to show up, I would appreciate it. Thank you.